Hey everyone, and welcome to this explainer. I am absolutely thrilled you're here with us today. Look, if math sometimes makes you feel a little anxious or overwhelmed, just take a deep breath. It's going to be okay. Today, I'm going to be your personal tutor, and we're going to make the topic of equal sets completely stress-free. Believe it or not, you actually already use the logic of equal sets in real life all the time without even realizing it. Think about when you're checking if two shopping discount codes give you the exact same items, or comparing two phone data plans to see if they offer the exact same perks. It's the exact same logic used when measuring land plots to see if they yield the exact same square footage, or even when an architect is making sure two building designs have the exact same foundational requirements. So today, we're really just putting a mathematical name to that everyday intuition. Here is exactly what we're going to cover today. 1. Welcome to equal sets. 2. The core logic explained. 3. An easy level with basic elements. 4. A medium level involving word puzzles. 5. The hard level with prime logic. And finally, 6. Your exam cheat sheet. All right, let's jump right in. Section 1. Welcome to equal sets, where we'll focus on seeing it before solving it. Okay, let's start by looking at three groups or sets of famous cricket players. We've got set A, set B, and set C. Now, just using your eyes and your everyday intuition, which two groups are exactly the same? Well, look closely at set A. It has Sachin, Dravid, and Kohli. Now, check out set C. It's got Kohli, Dravid, and Sachin. Notice anything? Right. Even though the names are in a completely different order, the group itself is literally identical. Set B, on the other hand, swaps out Kohli for Dhoni, so it's a different group entirely. So intuitively, without doing any math at all, you already know sets A and C are the equal ones. Section 2. The core logic explained. This is where we translate that visual intuition into math. You know what you just did visually with those cricket players? That is literally the entire logic of this topic. The formal definition on the screen says, two sets A and C are equal if every element in A belongs to C and every element in C belongs to A. Now, please don't let that formal wording scare you. All this really means is, do they have the exact same ingredients? Think of it like baking a cake. Whether you put the flour in first or the sugar in first, if the final ingredients are identical, it's the exact same cake. Simple as that.
Now, mathematicians love to save time writing, so they use this little shorthand rule you see here. I know, it kind of looks like a secret code, but let's translate it together to understand exactly why it works. That little sideways horseshoe shape, that just means is a subset of, or simply is entirely contained within. So, if set A is entirely contained in set C, and set C is entirely contained in set A, well, then they are equal. And that double-sided arrow right in the middle, that means if and only if. It's basically a two-way street, guaranteeing that both sides match perfectly.
Moving on to Section 3. Easy level basic elements. This will be your first guided practice.
All right, let's look at example 7 from our source. Step 1. Identify what's given. Set A contains the letters P, Q, and R. Step 2. Set B contains Q, P, and R. Step 3. We check the elements both ways. Does every single letter in A exist over in B? Yes. Does every letter in B exist in A? Also yes. Therefore, step 4. We can safely conclude A equals B. The absolutely crucial takeaway here is that the order of elements in a set absolutely does not matter. PQR is the exact same set as QPR. Section 4. Medium level word puzzles. Watch out for repeats.
Okay, notice how visually different these two things look. This is example 11. We're asked to compare set C, which is the letters in the massive word assassination, with set B, the letters in the word station. Now, at first glance, assassination is much longer, right? It has way more letters, it looks totally different. But let's go back to our core question. Do they have the exact same ingredients?
Here is the solution right from our source text. Take a close look at how they write the roster form for the word assassination. Now, I want to point out a very common mistake students make in exams here, writing down every single letter, including all the duplicates. But in set theory, if you have the letter A once, you already have it in your ingredient list. You don't write it again, you just don't count repeats. And this brilliantly illustrates why understanding the logic is so powerful. Once we drop all those repeating S's, A's, I's, and N's from assassination, we are left with just A, S, I, N, T, O. And when we do the exact same thing for station, dropping that extra T, we're left with, you guessed it, A, S, I, N, T, O. Suddenly, the giant word and the medium word shrink down perfectly to the exact same simple set. Set C absolutely equals set B. See? You've totally got this.
Section 5. Hard level, prime logic. Time for putting it all together.
All right, here is example 10, a real board exam level question. It asks, are the prime numbers smaller than 6 the same as the prime factors of 30? Now, I actually want to pause here for just a moment, read the question again, and think about what the given parts are before I show you the answer. It's kind of like a giant puzzle. You have to figure out two completely separate lists first before you can even start comparing them.
Okay, let's solve it step by step. Step 1. What are the prime numbers smaller than 6? Well, that would be 2, 3, and 5. So set A is the numbers 2, 3, 5. Step 2. What are the prime factors of 30? Meaning, what prime numbers multiply together to make 30? Well, 2 times 3 is 6, and 6 times 5 is 30. So set B is also the numbers 2, 3, 5. Step 3. We check both ways. Every element in A is in B, and vice versa. Therefore, step 4, A equals B. Beautiful logic, right?
Just to prove how incredibly confident you are right now, take a look at this exercise from the source. Question 1 asks, which of these sets are equal? Letters in the word follow, letters in flow, and letters in wolf. After our assassination example earlier, I bet you can do this effortlessly in your head. Follow drops the extra O and L to become F-O-L-W. Flow is F-L-O-W, and wolf is W-O-L-F. Exactly the same letters, just scrambled. They are all entirely equal sets.
Section 6. Your exam cheat sheet. Let's do a final recap and I'll share a special trick.
Okay, here is your 5-point cheat sheet. Number 1, order of elements doesn't matter. Number 2, repeated elements don't count. Always drop those duplicates. Number 3, every element must exist in both sets. Number 4, the master formula. Remember the shorthand. If A is a subset of B and B is a subset of A, that means they are perfectly equal. And number 5, here's your surprise exam trick. When checking, always test if A is a subset of B first. If even one element is missing, stop immediately. You don't need to check the reverse. They are not equal. Boom, you just saved yourself some really valuable exam time.
Let's leave you with one final thought. To test that exact trick we just learned. If set A is 1, 2, 3, and set B is 1, 2, 3, 4, why exactly aren't they equal? I want you to apply our master subset rule to figure that out on your own. Take this newfound confidence into your next homework assignment, because you have completely mastered equal sets. Thank you so much for learning with me today.